Yes, ma'am.
Yes, ma'am.
Okay, please put on your camera, everybody.
Ma'am, my camera isn't working.
Rida, okay. Others, please put on your camera. Okay, Mustafa, your camera is also off. Please put on your camera. Rida, what happened to your camera?
I don't know why it's not working. I tried opening it.
Okay, no problem. Okay. So yesterday we started with this lesson, square and square roots, and I gave you this homework also to learn the squares and square roots up till 20. So did you learn the square roots till 20? Children, did you learn the square roots?
No, ma'am. Till 13th, I learned. 13.
Okay, what about Mustafa?
Till 15 or 14, yeah.
Okay, no problem. But please keep revising every day so that you're able to learn them. And Rida, you also please noted that you have to start learning the square roots up till 20, from 1 to 20, okay? Then we came to properties of square numbers. So what was the first property of square numbers? That basically all the perfect square numbers end with certain digits. And what are those digits? 0, 1, 4, 5, 6, and 9. Okay, so all the square numbers will end with these digits only. Like 10579. This number is a perfect square or not, we can tell it just by looking at the figure. Looking at the last number. So here last number is 9, so it is a perfect square number. Then in 2, 3, 4, 5, 3, here the last number is 3, and we know that perfect squares do not end with 3. So it is not a perfect square number. Then we came to the questions as whether the given numbers are perfect squares or not, and which of the following are ending with what digits. So these type of questions we discussed. So all of these were easy questions only. Okay, we discussed one more important thing, that whenever I have the squares of two consecutive numbers, like I have 6 square and 7 square. So how many numbers lie between 6 square and 7 square? It depends upon twice the first number, smaller number basically, like 6 and 7. So I can consider 6 as n and 7 will be n plus 1. So number of non-square numbers or the number of natural numbers that lie between these two numbers are 2n. With this formula, you can find the answers. You can look at this question then. So does anybody have any doubts from yesterday's class?
No, ma'am.
No doubts, everything was clear?
Yes, ma'am.
Okay. Rita, so if you want to ask anything, so you can, because you were not there in the last class.
Yes, ma'am, because I have a variant, that's why.
Okay, no problem. But if you have any doubt, you wish to ask anything from whatever I revised just now, you can ask me.
Okay,
Then we'll move ahead. So the next question is, okay, so children, please look here. Today we shall start with the patterns of square numbers. So look carefully, what is the first pattern that we have? It says that adding odd numbers. Let's suppose, what is the first odd number with us?
1.
First odd 1. So 1 is, and what is the second odd number?
3.
1, 3.
So first number is 1 only. So 1 can be expressed as the square of 1 itself. So it becomes 1. When I add 1 plus the second odd number, it is equal to what? 4. So 4 can be expressed as square of 2. So 2 square is 4. Okay, what is the third odd number? 5. So it becomes 1 plus 3 plus 5, which is equals to 9. 9 can be expressed as square of 3.
3.
3 square is 9. Then I have, what is the fourth odd number? 1
7.
plus 3
7.
plus 5 plus 7. So this is equals to 16. And 16 can be expressed as the square of what number?
4.
4.
4. So 4 square is 16. Similarly, next square number is 9. So 1 plus 3 plus 5 plus 7 plus 9. So basically when I add 9 to 16 also, so I get 25. And 25 can be expressed as square of what number?
5.
5.
5 square is equals to 25. So there is a pattern which I can observe, that whenever you are adding consecutive odd numbers, so it is equal to the square of a natural number, right? Like sum of first 2 square numbers is 2 square. Sum of first 3 odd numbers is 3 square. Sum of first 4 odd numbers is 4 square. And then sum of first 5 odd numbers is 5 square, right? So the sum of first n odd numbers is n square only. The sum of first n odd numbers is n square. Very important. Now let's suppose I ask you a question. What is the sum of first 10 odd numbers? Now, one way of doing this question is that you are just adding all the 10 odd numbers. So what are the 10 odd numbers? First 10 odd numbers, 1 plus 3 plus 5 plus 7 and so on. You're writing all the odd numbers and then you're adding them. Okay, but this is very time consuming. So what can I do instead is, we know that the sum of first 10 odd numbers will be equal to 10 square root. So sum is equals to 10 square, which is equals to 100. That means sum of first 10 odd numbers will be equal to 100. If I ask you what is the sum of first 9 odd numbers, then what will be your answer?
81.
81. Okay, so remember this thing. The number of odd numbers that is given to you, your sum is equals to square of the number itself. Right, children? So these type of questions you can do. Now we come to the next type of question, that can you, like, is there any, okay, I told you about perfect square numbers, right? That like 25 is a perfect square number, 36 is a perfect square number, 49 is a perfect square number, right? So is there any other way of finding if a number is a perfect square or not? One way we discussed. What was that method? Looking at the last figure. So what should be the last figure? Out of which of the numbers should be the last figure? It could be
0, 1, 4, 5, 7, 9.
Yeah, it could be 0, 1, 4, 5, 7 and 9. Okay, this is the first method of discussing that whether a given number is perfect square or not. Now we have one more method. What we can do is repeated subtraction. Repeated subtraction. Now what is the method of repeated subtraction? Let's suppose I take an example, 25. And now I want to discuss, is 25 a perfect square number or not? So what will I do? I will keep on repeating odd numbers from 25. So first it becomes 25. What is the first odd number?
1.
1. So
One.
first I will subtract 25 minus 1. So what is 25 minus 1? 24.
24.
Then I will do 24 minus, what is the second odd number?
3.
3. What does it become? 21. Then I will do 21 minus, what is the fourth odd number? Third odd number?
5.
21 minus 5. What does it become? 16. Okay. Then I will do 16 minus
7.
3.
7. What does it become? What does it become?
9.
9. Very good. And then 9 minus
9.
9 only.
9.
So do I get a 0 at last?
Yes, ma'am.
After continuously subtracting odd numbers from the given number, I get a 0 at last. That means the given number is a perfect square. Right? Yes, 25 is a perfect square.
Should I write this down?
Yes, you can. You can keep noting down the things. These things are also there in your textbook, Rita. So you
Yes.
can skip noting also because it will hinder your focus from the class. So you can just focus on the class right now. And
Okay.
after the class, you can refer to your textbook and then you can just look at these things over there. Everything is there in your textbook. I'm not teaching from anywhere else. Okay, so 25 is a perfect square. Now, if you look carefully, I can also tell that what number on squaring what number do you get 25? Okay, that means 25 is the square of what number? How can I tell? Okay, how many numbers did I have to subtract? 1, 2, 3, 4, and 5 numbers. That means 25 is the square of 5. Okay, so I again get a pattern that on repeatedly subtracting odd numbers, I can easily guess whether the given number is a perfect square or not. And if yes, then of which number is it a perfect square? So is this method clear? So we will consider one more example. Let's consider 38. So let's check for 38 now. First, I will subtract 38 minus 1, gives me 37. Then I will do 37 minus 3, it gives me 34. Then I will do 34 minus 5, gives me 29. 29 minus 7 gives me 22. 22 minus 9, 13. Then 13 minus 11, this gives me 2. And 2 minus 13. So what does this give me? It gives me minus 11. Now I do not get a 0. Instead, after the positive numbers, I'm getting a negative number over here. That means 0 will not come. Even if I keep on subtracting, see, then I will subtract minus 11 minus 15. Again, I'll get a negative number. That means I'll not get 0 now. If you look at the number line, you have positive numbers, then you have 0, and then you come to negative numbers. Now I've directly come to negative numbers. That means 0 will not be there. So is 38 a perfect square or not?
No.
No, it's not a perfect square. Okay, and why is it not a perfect square? Because on repeated subtraction, you get a negative number. Right, children? So this is a very important way of discussing whether given number is a perfect square or not. So next is, okay, so one important point to note is that if any number is a perfect square, so it can be expressed as sum of odd numbers. If a natural number, my voice is being equal. Is it being repeated to you as well?
Yes, ma'am.
Yes.
Okay, let's try now. If a natural number cannot be expressed as a sum of consecutive odd numbers then it is not a perfect square. Okay, children, remember this thing. If you're not able to, this gives us the idea that perfect square numbers can be expressed as the sum of consecutive odd numbers. Like we studied previously also, this was the pattern that on adding odd numbers, we get a perfect square number only. Okay, so this is related to that thing. Is this much clear to you all?
Yes, ma'am.
Yes.
Okay, so now we can do one question. Find whether each of the following number is a perfect square or not. 121 and 69. Okay. So what method will you use? You will use the method of repeated subtraction. Okay. Children, done? Shall we discuss? Then please respond. If you've completed, then we shall discuss.
No, ma'am, I'm doing second part.
No, ma'am.
What about Rida? Rida, are you able to do the question? Rida, are you there in the class? Rida, please respond if you're there in the class.
Done, ma'am.
Okay, children, so we shall start discussing. If you look at the first question, it is 121. So what method will you use to check if it is a perfect square or not?
Ma'am, repeated subtraction.
Yes. So by repeated subtraction, you have 121 minus what? Tell me the solution, Mustafa.
Minus 1 is equal to 120.
Okay.
Then
120 minus 3 is
120 minus 3.
Karmi, you can tell me the B part. Let Mustafa tell this part. Okay. One by one, I'll give you chances.
Okay.
120 minus 3 is 117.
Okay.
Okay.
117 minus 5 is 112.
Okay.
112 minus 7 is 105.
105. Okay, correct.
105 minus 9 is 96.
Okay, good.
96 minus 11, 85.
Okay, next.
85 minus 13, 72.
Correct. Next.
72 minus 15, 57.
Yes, 57. Correct.
57 minus 17, 40.
Okay, then 40 minus 19.
21.
Yes. And
21
21
minus
minus 21, 0. So is this a perfect square or not?
yes, ma'am.
Okay, and which number?
11 square.
11 square. Because how many numbers have we subtracted? We subtracted 11 numbers. So you will write yes, 11 square is equals to 121. This is how you can do. Okay, next you come to 69. Yes, Harmin, tell me the solution for it.
Yes, ma'am. So first is 69 minus 1.
Yes.
Um,
Yes.
it gives 68. Then 68 minus 3
Gives you
65.
okay.
Then 65 minus 5,
Okay,
that gives 60.
good. Then
Then 60 minus 7,
it gives you 53.
uh, yeah, 53.
53 minus
Then
9,
53 minus 9, it
44.
gives 44.
Yes. 44 minus 11.
Then 44 minus 11, it gives 33.
Yes. And 33 minus 13.
33 minus 13, it gives 20.
20 minus 15
Then
gives 5.
20 is 5. 5 minus 12.
So is it a perfect square or not?
Mm,
You think it is a perfect square, 69?
9.
Tell me, Armin, you think it is?
At last, how we could find that? Like, according to even numbers or odd numbers?
No, you find it if you're getting a 0 at last or a negative number at last. Okay, if you get a 0 at last, so it means it is a perfect square. And then you count how many times you've subtracted, and then that's the answer. Okay, like the first part. So is that thing clear? If you get
Yes,
a
ma'am.
negative
It's
number,
not.
that means it is not a perfect square. Okay, if you get a negative number, like here you're getting minus 12. So that means 69 is not a perfect square. Okay, why? Because you got
Yeah.
a negative number at last. Now
Minus
you'll just
2,
stop here.
minus
You'll
2.
not subtract ahead. You'll just stop here
Yes,
and you'll
ma'am.
write, since we're getting negative number at last, hence it is not a perfect square. Understood?
Yeah. Yes, ma'am.
Ma'am, I have
What
a
if we
question.
get a positive number instead
See, if no,
at the
you have to keep
last?
on subtracting until you get a 0 or a negative number. Like you can't leave at positive number. Yes, Mustafa.
Ma'am, there was a method to check the last number, right? 01457.
Exactly. Yeah, I know your doubt. I was just about to discuss that point only. See, now why we have this method? See, the first method was just to check whether a given number can be a perfect square or it cannot be a perfect square. Okay, it was not a specific method to tell you, okay, all these numbers will be perfect square only. It was not a fixed method. It was just that all the numbers which are perfect square ends with these numbers. But it can also be the case where there are various non-perfect square numbers which are also ending with the same number. So that is the case. Now what happens? Now 69 can be a perfect square or it cannot be a perfect square. 121 can be a perfect square, it cannot be a perfect square. Okay, and first we will follow the method of checking with the last number. So I checked with the last digit, I'm getting yes for both the answers. But it is not a fixed answer. Why? Because see, we might also have numbers like 69 is one of those numbers which is ending with 9, but it is not a perfect square. So we will check with another method, which is the repeated subtraction. All right. Now see, what we are discussing, how the first method helps us is, it helps us in segregating those numbers that can never be a perfect square. For example, a number ending with 3, it can never be a perfect square. So instantly, I don't even have to do repeated subtraction method. I can just instantly tell, okay, the last number is 3. I know it will never be a perfect square. Do you understand that?
Yes,
But
ma'am.
for the numbers which are ending with certain digits, so for them, you have to check for the perfect square method, for the repeated subtraction. All right, so you do it stepwise, but in exam, always look at the question what they are asking you to do. If it is given that what is the last number of this on squaring this number, or check by last digit, then you will write according to the question your answer. If they're asking you to do the repeated subtraction method, then you will follow this method. Okay.
Okay, ma'am.
Yes. So we come to the next thing now. Okay, sum of consecutive natural numbers. So let's suppose you have 3 square. This is our third pattern. Now what is 3 square equal to? It is equals to 9. Now can I express 9 as a sum of any 2 consecutive numbers?
Yes, ma'am.
What are those numbers? Okay, tell me.
Ma'am, consecutive odd numbers.
No, not specifically odd numbers, consecutive natural numbers. Can be even, can be odd. Can I express 9 as 4 plus 5?
Yeah, I was gonna say that.
Yes, it can be expressed as 4 plus 5. Now 4 and 5 are what numbers? They are consecutive natural numbers. Right, children? So what happens? Now this is a small example of 3. Now similarly, any square number can be expressed as the sum of two consecutive natural numbers. Now here my question was very small, like I was asking you for 9 only. Now I can also have bigger numbers. Let's suppose 121 only. We just now checked that 121 is a perfect square number. Now, what if the question says that find two consecutive natural numbers that on adding them you get 121? Okay, now that will be difficult to guess. So we have a method for checking these consecutive numbers. And what is that method? These consecutive natural numbers, can I say them as this is the first number and this is the second number? So first number can be expressed as, okay, can I call this 3 as n? Okay, I'm calling it as n. So first number becomes n square plus 1 by 2, and the second number becomes n square minus 1 by 2. Now let's check. So this is my general formula now. So if my question is 3 square, so what will be 3 square? It will be equal to 9. And now I have to check which two numbers can I represent. So first number will be equal to n square plus 1 by 2. That means 3 square plus 1 by 2. That means 9 plus 1 by 2. That means 10 plus 2, 10 by 2. So it becomes 5. And what does my second number becomes? It becomes 3 square minus 1 by 2, 9 minus 1 by 2, or 8 by 2. Hence you get 4 as your answer. Okay, children. So it can be expressed as 5 plus 4. So this way, can you do such questions? Now let's come to that question that I was asking, 121. Okay, 121 is the square of which number?
11.
11. So 121 can be written as 11 square. Now the two numbers will be 11 square plus 1 by 2 and 11 square minus 1 by 2. That means 121 plus 1 by 2, that becomes 122 by 2, which is 61, and 121 minus 1 by 2, that means 120 by 2, that becomes 60. Hence 121 can be expressed as 121 becomes 60 plus 61. Okay, children. So this is one way of finding that how can you express a number as a sum of two consecutive natural numbers. Okay. So what are the two patterns? See, now if you look very carefully, the first pattern that I taught you was that any square numbers can be represented as a sum of two odd numbers. If you remember it, okay, it can be represented as sum of two odd numbers. And similarly, the second pattern that we come across is it can also be represented as the sum of two consecutive natural numbers. So is this thing clear to you all? If you
Yes,
notice,
ma'am.
9 was being also represented as 1 plus 3 plus 5. So it can also be represented as sum of consecutive odd numbers, and it can also be represented as sum of two consecutive natural numbers. So that you should not be confused. The difference between how is it being represented as odd number and how is it being represented as sum of natural numbers. These are two different things, two different patterns. Okay, children? Like if I ask you that 9 is the sum of how many odd numbers? So your answer will be 3. Why? Because 9 is a square of 3. Similarly, if I ask you 121 can be represented as sum of how many odd numbers? So what will be your answer?
11.
11. Very good. And if I ask you it is a sum of what two natural numbers, then how will you solve it?
61 plus 60.
First number and second number. So you'll do 121 plus 1 by 2 and 121 minus 1 by 2. So both the methods, don't be confused. These are two different types of questions. Okay, children? So next we come to, okay, here you have a question. Express the following as the sum of two consecutive integers. Okay, what are the questions? 21 square and 11 square and 19 square. Okay, so children, please do this question.
Uh,
Yes, Mustafa.
Nothing, ma'am.
You have any doubt? We can rediscuss.
No, ma'am. Nothing.
You're able to do, children?
Yes, ma'am.
Okay, please.
Done, ma'am.
Okay. So let's discuss. Harmeen, have you also completed?
No, ma'am, I'm the third one.
So we shall discuss when you can do it with the class only. Okay. So we come to the
Okay,
first
ma'am.
question. Harleen, you can tell me the first one.
Yes, ma'am. 21 square is equal to 441.
440. No, it's not 440.
No, ma'am, 441 I said.
Okay, 441. Then
Then 21 square plus 1 by 2.
you will write like this. First number
Yeah, first number
21 square plus 1 by 2. So this becomes,
becomes 441 plus 1 by 2,
yeah,
which is 442 by 2, which gives 221.
okay. And then second number,
Yeah, second number 21 square minus 1 by 2.
okay, that gives you
That gives
440 by 2.
441 by 440 by 2.
So
That
220.
gives 220.
Okay, good. So
So
we have
yeah,
221.
441 is equal to 221 plus 220.
Yes, good. So come to the second question now. Mustafa, can you tell me the second one?
Yes, ma'am. 11 square is equal to 121.
Okay,
So it will be 11 square plus 1 divided by 2. First number.
yes. So it becomes 122 by 2.
Yes, ma'am.
261.
Then 11 square minus 1 divided by 2. And that becomes 120 by 2, which becomes 60.
Yes. So the numbers are
60
61
plus.
and 60. Third one. Who wants to tell the third? Harmeen didn't do the third one. So Mustafa, you can only tell.
Yes, ma'am.
Ma'am,
Uh,
I did.
Okay, you've done.
And
So
the
tell me
first
the
one
third.
I did.
Have you done the
Ma'am,
third
me?
one, Harmeen? Whoever
No,
wants
ma'am.
to tell me, you can. Who wants to tell?
Ma'am, 19 square is 361.
Okay.
So 361 by 2, 361 minus 1 by 2, 361 plus 1.
So 362 by 2, first of all. So it becomes,
181.
and second number becomes 3
360 to
by
180.
2, 180. Numbers are 181 and 180. Okay, children, clear with this question?
Yes,
Yes, ma'am.
Okay, so we shall move ahead now. Let me see, is there any other thing remaining? Okay, there's one more property, one more pattern which says product of two consecutive odd or even numbers. Now, let's suppose I have two consecutive odd numbers which are 11 into 13. So what is 11 into 13? 160, 143. So 143 is equals to, now 143, we know it is not a perfect square. See, now that was the reason that I told you in the first class only to learn the perfect squares up till 20. Okay, because in such type of questions, it's easier to come to the solution. Like 143, we don't know it's a perfect square. Why? Because I know the perfect square of 12. What is the perfect square of 12? Did anybody learn?
144.
144. Okay, so that means 144 was a perfect square. Hence, 143 can't be a perfect square, right? So now tell me, can I express? 143 as 144. Okay, what relation does it has with 144? It is a smaller number. And by what factor? -1. So I can express 143 as 144 minus 1. Now what does this become? 144 becomes 12. So it becomes 12 square minus 1. That means 11 into 13 can be expressed as 12 square minus 1. Right. Let's look at more examples. Let's suppose I have 13 into 15. So what is 13 into 15 now? 165. Can anybody tell me that is 165 a perfect square or not? Did anybody learn the square of 14?
No, it's not a perfect square.
Why? What was the square of 14?
196, I think.
No. Did we multiply 13 into 15 wrong? Wait, yeah, we multiplied it wrong. It should be 195. Okay, children, this is 195, okay? So, we know that 196 is a perfect square. So, again, 197. So, 195 can be written as 196 minus 1. And 196 is a square of what number? 14. So, 14 square minus 1. So, we know whenever I will have two consecutive odd numbers, like I had 13 and 11. So what was the middle number? 12. So 13 into 11 can be written as 12 square minus 1. Okay. Similarly, 13 and 15. So 13 and 15 can be written as what was the middle number? 14. So it can be written as 14 square minus 1. So let's suppose I say, now let's take even numbers. This is also valid for even numbers. Let's say I take 44 into 46. Now what is the middle number here?
45.
45. So can I write it as 45 square minus 1?
Yes.
Okay, this will be true. Children, now if you look very carefully, so this is actually not a very different thing. This thing you've also studied in lower classes in 7th standard when we used to study. Have you studied this identity? A plus B, A minus B is equals to A square minus B square. Have you studied this identity? Please tell me, children. Have you studied this identity or not?
I don't think so, ma'am.
In 7th standard, it was there. It's there in algebraic expressions. Okay, so see children, this is an identity of algebraic expressions that whenever I have two numbers and I square them and subtract them, so it is equals to the sum of two numbers and the difference of two numbers. So let's say I have 5 square minus 3 square. So what does it become? It becomes 5 plus 3 and 5 minus 3. Okay, so this is this identity. This is how we solve it. So remember this thing now. Now let's come back to this question. Now look very carefully. What do I have? I have 44 and 46. So I can represent 44 as 45 minus 1 and 46 as 45 plus 1. Isn't it? I can represent it like this. So isn't it obvious that now this actually is this a square minus b square? It's the same identity. A plus b, a minus b. Right? So this can be written as a square. What is a? 45 minus b square. What is b? 1. So 1 square. Either you can write like this or you can just directly write 45 square minus 1. Okay, this is, see, you don't have to remember all of this thing that I told you. It's just for concept clearance. That you should know how 45 square minus 1 can be represented as 44 into 46. Okay, what is the logic behind that? So this is actually the logic. It is not any short trick. It is just a short form of writing this entire thing. Okay, children? So do you understand that whenever I will have two consecutive odd numbers or two consecutive even numbers and I find the product of those numbers, then what will happen? I will represent it as the square of the middle number minus 1. Okay. Any doubts in this pattern? Understood?
Yes, ma'am.
Good. So remember this, that whenever I will have a plus 1, a minus 1, so it is represented as a square minus 1. Okay. So we will just quickly revise all the patterns that we studied in today's class. So we started with this topic, patterns of square numbers. So first pattern that we started was adding odd numbers. So whenever you're adding consecutive odd numbers, so the answer is always a perfect square number. Like 1 gives you 1 only. So 1 is also a perfect square of 1. Then 1 plus 3 gives you 4, which is again a perfect square. 1 plus 3 plus 5 again gives you a perfect square. That means whenever you're adding consecutive odd numbers, answer is always a perfect square number. Okay. And how can you just find the sum of first n odd numbers? It is always equal to n square. Like if they ask you what is the sum of first 10 odd numbers, your answer is 10 square, means 100. Okay. So is the first property clear? Is it clear?
Yes, ma'am.
Okay. Then we come to the second pattern, which says that repeated subtraction. This pattern tells you that if you have to find out whether a given number is a perfect square or not, you keep on subtracting consecutive odd numbers from it. Like to find if 25 is a perfect square or not, you will first subtract 1. Then from the answer, you will subtract the second odd number, which is 3. Then the third odd number, which is 5, 7, 9, 11, 13, 15, 17, 19, and so on. You will just keep on repeatedly subtracting the odd numbers. And if your answer comes out to be 0, then your given question, the number in the question is a perfect square. If your answer is a negative number, then it's not. Okay, so will you remember this thing?
Yes, ma'am.
Then we practice some questions based on it. Then next you have sum of consecutive natural numbers. So we studied that any perfect square number can always be represented as a sum of two consecutive natural numbers. Like 9 can be represented as 4 plus 5. Okay, then we studied 121 can be represented as 60 plus 61 and so on. So how to find these consecutive natural numbers? We have a formula which is n square plus 1 by 2 and n square minus 1 by 2. Then we have then we practice some questions based on this. Then we finally came to the last pattern, which is that the product of any two consecutive odd numbers or consecutive even numbers is always equal to the middle number square minus 1. So if I have like 11 into 13, so which number are we skipping? 12. So 12 square minus 1. If I will have 13 into 15, my answer will be 14 square minus 1. If I give you this question, if I say 99 into 101, so what will be your answer?
100 square
Minus
minus
1.
1.
Okay, children. So this is how you solve such type of questions. Now I'll do one thing. I will just share these class notes with you all. Please maintain a notebook where you will write all these patterns. Okay. You can either do one thing. You can also write all these patterns on a paper and then stick it in your book. Because in your book, I just checked, these patterns are like it's better to write it in this way. Okay. It's easier to understand in this way. In your exam, you can just quickly revise all the patterns, all the formulas, all the important points of those patterns, how to solve questions based on them, and then you can uh, revise like this. Okay, children. So any doubts if anybody has from today's class?
Ma'am, I have a doubt. I'll put the question in the chat.
Is it a okay? You've already put the question in the chat. The age of Rahul and Rohan. Okay, this is the question from the test. So Mustafa, yeah, I was just about to discuss this only about the test thing. Now this question most of the students have done wrong. And also I have to discuss the test questions. I wasn't discussing the test because the other children are not present in the class. So we'll see in the next class if others will come or not. We'll discuss the test. Okay.
Okay.
I wanted to discuss the class test with you all. So sit with your notebooks, wherever you have solved the test. In the next class, we'll discuss those class test questions, and whatever doubt you have, you can ask me in that. Okay.
Okay.
Clear, children? Any other doubt?
Yes. No, ma'am.
No, ma'am.
All right. So, children, for today, we'll just keep it up till here. You can go for now. Rest we'll continue ahead in the next class. Okay, please revise properly whatever we studied and also practice questions